2a, it tells you to factor each polynomial over the set of complex numbers and explain why you chose the factoring method you used. So one key word that I'm just recognizing right now is just factor. We'll worry about the over the set of complex numbers if we need it later. I have a trinomial. Class, what's half of 4? 2. So now we can use x in your box. A times c. How much? 18. Brendan, b value? Brendan, your two numbers? 9 and 2? Did you say 9 and 2?
No. 9 and 2.
Oh, sorry.
And then 2.
Yep. Let's just show everyone, although it's just an a value of 1, you don't need the box, but some of you guys can't visualize what an answer would be. So let me show you the answer, what it is without the box. You have -9 and +2. But class, can I put x and x here? No. What do you have to put? X squared. Okay, let's see if you didn't see that. Let's just use the box. Tony, what goes in the top left of the box? X to the what? Yep. Here? Yeah. Remember, this yellow part's splitting the middle term. Keep going, Tony.
2x
Fidel? What goes on the top here? Good. Here? Good. Here? Good. Good. So that would give us the same thing. X squared minus 9, x squared plus 2. Put your finger on the one that you can keep factoring. Marisol, which one of these can we keep factoring? What are you saying, Marisol? Correct. You're going to have to add a 0x here. The reason why that you can't do it over here is you put a 0. A times c is 2. B value is 0. There are no two numbers that multiply to be 2 and add to be 0. This will be -9 and 0. Ingrid, what two numbers go here? Both negative? Just one of those. Correct. So my answer is going to be from here, x plus 3, x minus 3, and then the x squared plus 2. Now, this next step, even though it does ask for it, it says over the set of complex numbers. I'm probably going to accept this as full credit for factored. Let me show you if you wanted to know how to do it by what they're asking you. And it actually involves just actually doing the next step, which is identifying your zeros, and I asked you guys to graph this. You would subtract 2 from both sides, and you'll get x squared equals -2. Jeremy, how do you get rid of the power of 2?
Square root.
Alright, dangerous territory. Let's see what you got. What do we got as our answer?
2.
What are the factors of negative 2?
Negative 2 and 1.
Negative 2 and 1?
2 and negative 1.
And what is the square root of negative 1?
I.
So this would give us the I. And radical 2. And is this your answer?
No.
Alex?
No.
So what do I need to have here?
Plus or minus.
Yeah. So a super clean answer, if you really wanted to know over the complex, it would have looked like this: x plus 3, x minus 3. Then you're going to substitute this one in there. So that would be a plus I radical 2. So plus is just a positive. And then the negative. And of course that would just turn into plus. So we got lucky here where we didn't have to use the quadratic formula, but the quadratic formula, did you get that? You would have still gotten that. Okay. This kind of helps us identify that this has complex solutions, so we'll not cross the x-axis. Here we already know that this is going to be 3 and negative 3, right? If you set each of those equal to 0. So x equals negative 3, x equals a positive 3. Put your finger on the degree of the polynomial. We have a even degree polynomial. Now about the arrows, this is called the end behavior. Class, where are they? Both up? And through negative 3, is it going to be a shoot through or kiss?
Shoot through.
Yeah. Remember the odd multiplicity means shoot through. Let's go ahead and sketch it. And then we also talked about previously how you can use the y-intercept of negative 18. So it might look something like this. I don't know. My roller coaster. And you'll notice that these are the reals, and then the complex, the i's. You'll notice it doesn't go through the x-axis there. So that was question 2A.